A little time and talk to you about some things concerning domain and range with a few trigonometric functions, and a little bit about one-to-one functions in general, and then some topics about inverse functions within the trig functions, and are they one-to-one? What are one-to-one functions and things like that. So I'm going to look at this handout here and look at a couple of problems. This first problem says, what is the domain and range of y equals cosine x? This is something that should be easy and straightforward. If you recall, when we graphed the parent function cosine x, one period of that, we have the 5 critical points starting at the origin. We have the range rather of the parent function of cosine is -1 to 1, and when we graph this, cosine starts up here and it comes down through this first critical point at the x-axis and down midway at this middle critical point to the -1, back up here, and then back up to here, giving us this almost like a U-looking shape. And remember, this is just one period of the cosine function. This goes on forever, okay? Forever in the positive direction and forever in the negative direction. Therefore, that tells you that the domain is going to be all real numbers, and the range is going to be -1 to 1. And hopefully that helps you. You can write that in different ways. If you want to write the domain and range in interval notation, you could just write it like this, and that'll work. Okay, continuing on. I'm going to skip ahead here and look at number 3 before I look at number 2. It says true or false. For a one-to-one function, if y is equal to f of x, then x is equal to the inverse of y. What this is saying is that we have this function y is equal to f of x, and what happens here when we solve for x, what we've done is we've taken the inverse function of y. And it's one-to-one. What it means by one-to-one is this. One-to-one functions means that the function is a function, so this is a function, and its inverse is a function as well. Okay, so if a function is a function and that function's inverse is a function, then it is one-to-one. So what this is saying is if y is a function of x, right here, then x is a function of y. It's one-to-one. The answer is yes, it is true, because of what I just stated. Because the function is a function and its inverse is a function. That's what one-to-one means. Now, using that information and going back to number 2, it says true or false. For a trig function, if y is equal to f of x, then x is equal to capital F, the inverse of capital F of y. Remember when we talked about trig functions? Let me clear this out. And their inverse. I'm going to pull up the slide. This table was given to you within the curriculum. And basically, if you recall, sometimes when we had the trig functions, when we found their inverses, they were not functions over the entire domain of all real numbers, okay? Because they would fail the vertical line test. For example, you may have an inverse trig function that looks like this. Well, as you can see, this would fail the vertical line test. But if I restrict the domain on this and don't include any of these values up here, if I restrict the domain on the function itself, then this piece would be a function. So what this problem is talking about And before I go back to the problem, really quick, notice how, remember the capital letters indicates that this is a function and not just a relation, therefore it would pass the vertical line test. The inverse sine function, that's domain, is restricted from -1 to 1. But recall when we had y equals sine x, its domain was all reals. Just like when we just got through talking about y equals cosine x, its domain was all real numbers as well. Okay? But when we have the inverse cosine function, capital C, its domain has to be restricted because of the fact that it just simply won't pass the vertical line test. There are values there that are invalid that restrict it from being a function. So we restrict the domain so that we can make its inverse be a function defined over a specific domain, in this case for cosine x of -1 to 1. Now with that being explained, let's kind of go back to the problem. So what this is saying here, for a trig function, so that's where these tricky rules come into play. If we have a function, then its inverse is a function as well. And the answer here is, we could say true on restricted domains for some functions. However, this question is saying this would mean that because there's not a restriction here, it's not telling us a restriction here, we would have to say false. Now, I hope I'm not confusing you, but the answer would be true if we could restrict the domain to certain values. But it's false if they're expecting us to use all real numbers, the same domain as y has over here. Okay, so make sure you're really paying attention to these notes and making that connection between these trig functions and when we're talking about their inverse functions, that the domain is not necessarily the same. And check out the graphs that you're given within the section. That will help you a lot. And keep in mind the vertical line test.